Yeah. It's been a long night for me, so if I completely botch this, I apologize in advance. And should I completely botch this, I'll do a clean job of it later. Um, I do not have any problem defining terms. If there is a problem with defining terms, if anything, it's that I'm too strict. Something that would be perhaps helpful here is that bearing in mind that, yeah, philosophy guy, but I'm more of a math guy. Um, in particular, philosophy of math. These two fields overlap quite a lot, and overlap in ways that I just find endlessly interesting. So, defining terms. Note that I said given definitions for 2 plus equals and 4, and you can't really skip that one. Can't really skip that one. Because if the term 4 is itself undefined, and we could even just define it as the number that results from 2 plus 2. Um, if 4 is undefined, then our expression is still ambiguous. Um, so, note that I say that for these definitions, uh, 2 plus 2 does equal 4. Here's where we get into some difficulties, because you were talking about the properties of the things concerned not really being pertinent, and they are absolutely pertinent. In particular, let's go to some of these definitions. Let's look at these definitions. Um, Plus, yes, is simply an active aggregation, but here it is an active aggregation that is an implicit appeal and implicitly relies upon one of the general definitions of arithmetic, which we find specifically instantiated in our definitions for 2 and 4, that being the commutability of property. That I can take 1 and 1 and 1 and 1 and say that I have 4. That there is nothing specific to these things which would preclude my considering them as a case, or as an aggregate. That's one of the definitions that we require in mathematics, and one of the definitions that it relies on. Commutability is not something that we can extend much beyond the realm of the abstract. And here I think we by and large agree that this notion of commutability, that this 2 plus 2 equals 4, is an expression of something that we can do abstractly, maybe even symbolically, but we can't consider it a serious reflection of how general bodies in the physical world actually behave. Um, just this notion of free transposition of property and commutability. Well, by way of example, we're going to go 1 plus 1 plus 1 is 3. Now, the moment I have considered this a 3 in an operation of aggregation, the differences between these objects have been discarded. Works great in abstraction so long as we're simply using our numerals and our enumeration as an abstract reference to a case, but it doesn't work very well in specifics. The other thing that I find kind of amusing here is that even mathematics, slightly more complicated systems of mathematics like set theory, um, allow for more complicated sets of more complicated expressions. of aggregation. You use the example of blobs, where I have one blob that I add to another blob, and you say that you said that in arithmetic, well, you didn't say this in as many words, but in arithmetic we would consider that 2. In set theory we would consider it 1. The set expression to aggregate those would, if we are considering each of those blobs as a set, we would wind up with a result of 1. There are other systems of calculation which would also render that expression as 1. And one of the reasons that mathematics develops these more involved or more obtuse systems of resolution is recognition that the simplicity of arithmetic very, very poorly represents any number of specific problems that we would attempt to apply arithmetic to. That there are things which we seek to represent numerically and seek to predict or anticipate mathematically that simple arithmetic does not in and of itself really allow us to do. So, anyway, yes, given the definition of 2 plus equals and 4, and given the overarching context of the general rules of mathematics, 2 plus 2 equals 4. Extending it much beyond that, or taking exception with any one of those propositions, any one of those givens from which we are arguing. And things get very messy very fast. So, cheers.